Hi folks, Mr. Long here. I'm going to do a quick screencast on the algebra of E, which is Euler's number. It's the number 2.718, and it represents the rate of the base at which the rate of change of an exponential function is equal to the function. I'll keep repeating that over and over again. So just to go through some exponent law stuff. So if you have e to the exponent 1, for example, what is that? That's 1 over e. In case that negative 1 indicates divide by e once. 1/2 is square root of e. Okay, this is when you're simplifying. Negative 1/3, well, 1/3 indicates cube root. Negative means division by. So that's cube root of e. If you see 1 over e to the x, so 1 over e to the x can also be written as e to the negative x. This one's a little bit more difficult. 1 over e to the negative 2 really means e to the 0 over e to the negative 2. And because anything can be represented with a base to the exponent of 0 for 1. And then I would have 0 subtract negative 2, which is e squared. Okay, so those are some simple exponent rule things that you probably should remember. These also refer, of course, to reciprocals. So the reciprocal of e to the x is e to the negative x. Okay, folks? The reciprocal of e to the x is e to the negative x, and you're going to see that that can become important. So we're going to solve this equation here for z. Okay, for z. So the first thing we want to do is isolate the constant terms on one side. I'm going to isolate them on the right side. So the first thing I'm going to do is to subtract 7. That gets rid of that. We'll have 15e to the 1 minus 3z will equal 10 minus 7 is 3. Next thing we need to do is undo that multiplication, divide by 15 on both sides. E to the 1 minus 3z equals 3/15. But 3/15 simplifies to 1/5. So I have e to the 1 minus 3z equals 1/5. Now, what I can do here is, once I get to this point, it's just like when you were working with base 10 exponents. We used to take the log of both sides. Now we can take the ln of both sides, right? Because the ln of this, if I ln both sides, then I will have this. Okay, so I should have done that in the same color, ln of both sides. Now, what is the ln of e? Well, the ln of e is 1. So what this represents is just 1 minus 3z. What does this equal? Well, we know by our rules, our exponent rules, that this is actually ln 1 minus ln of 5. But what is ln of 1? That's 0, right? That's 0. So that's ln of 0. So what we have is 1 minus 3z equals negative ln of 5. And now what do I need to do? Subtract 1 and divide by negative 3. Okay, so it's going to become negative 3z equals negative ln 5 minus 1. And then I need to divide each of those by negative 3, negative 3. Z then equals, we've got a common denominator, and 2 negatives make a positive, 2 negatives here make a positive, and I end up with ln 5 plus 1 all over 3. Okay, that's just a reminder. So the solving is exactly the same as in your logs unit from advanced functions. Okay, folks, so again, pause, rewind, take a look at that. The big idea here is that the ln of e to the x is just x, right? Because they're inverse functions and they're undoing functions. Okay, folks, have a good day.